Hey folks, welcome to the video on carboxylic acid. So in this video we'll talk a little bit about their formula, how to name them, what the ending looks like, and also we'll talk a little bit about how to draw structural diagrams and some of the general properties of carboxylic acids that in areas in society we might actually see them being used. So the first thing that I want to mention is the formula is an R, and remember, as in all of our series of videos, this R is representing a hydrocarbon, and a hydrocarbon is exactly how it sounds. It's some carbons with some hydrogen bonded to it, okay? But then here is our carboxyl group. So we're going to have a carbon, a double bonded oxygen, or an oxygen which is double bonded, and a hydroxyl, okay? So this is our this is called a carboxyl group. So now take a look at this carboxyl group here. We're going to have our carbon, and notice that there's this double bonded oxygen and a hydroxyl. So we call this double bonded oxygen, we call this to this carbon, call this our carbonyl, and this is our hydroxyl. So you might want to recognize those words, okay? So if we take a look here, in a conversion, if we were to convert alcohol to carboxylic acid, notice that this is an alcohol and it just has the hydroxyl attached, so the OH attached to the hydrocarbon, and so it's called ethanol. But if we were to convert it, basically what would happen is we would just be adding this double bonded oxygen here, and it's basically the exact same structure, except for we are going to take out this one bond, we're going to add a double bond, we're going to have to take out some hydrogens, but we add that hydroxyl group. But what we are looking at is this right here. You have to be able to recognize this. Now, do you have to memorize this structure? It would be helpful because it'll solidify your understanding, but at the same time, it's in the data booklet, and we talked about it in the introduction to organic compounds. It's in there, and so it tells you it gives you examples how to name the sections. Easy if you know how to use your data booklet and utilize areas that they help you in the class. So one thing to know about carboxylic acid is it ends in ic, then the word acid. So you can see that right here, and like I said, it's a carboxyl group. So we'll move on to the naming rules for carboxylic acid. So first thing we always do is we want to determine what the parent chain is. So for example, methanoic acid, we would look at the parent chain. So that O should actually just be here, it just is moved. So this is bee sting, okay, so it's formic acid. And so what happens is we have this carbon, double bond, oxygen, and the hydroxyl here, so our carbonyl up here. So that's 1, 2, 3, 4 bonds, but this is what we're looking for right here, okay? That's how we know that's a carboxylic acid. Now, how do we name it? There's one carbon, so we go methane. We get rid of the E, we drop the E, and we add oic acid. And so that's what we've done here. Drop the E, and now you can actually see this oic here and acid written, okay, and then common name formic acid. All right, down here again, that O should be right here, not there. And so here we call this ethanoic acid. How do I know it's ethanol or ethanoic? Because 1, 2 carbons is our eth, and I'm seeing this right here, this carbon, this hydroxyl, and this carbonyl attached. Then I know it's going to end in oic acid, so ethanoic acid. So if I was to draw one more, I have a carbon, 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 carbon. All of these would have bonds on them here, and hydrogens bonded to it. And then here I have this. So what would I name this one? Well, first I have to look over here to my carbons. So I have 1, 2, 3, 4 carbons. So now I know that's going to be bute. So butane, but it's a carboxylic acid because I can see that carbon, my hydroxyl, and my carbonyl. So I'm going to end it oic acid. So hopefully you can understand that. So some drawing rules here as well that we need to understand. So when I draw it, I want to make sure that I am looking at the parent chain. The first thing I want to do is write my, or I want to draw my carbon chain. Then after that, I'm going to add this to the end. So if I recognize that it's oic acid, I know that this is exactly what I'm drawing on the end of the last carbon. So if I was to give you this hexanoic acid, you would be able to draw hex, giving us 6 carbons, 1, 2, 3, 4, 5, 6, and oic acid telling us that it has to have this carbonyl attached to the last with the double bonded oxygen and this O hydroxyl attached. Okay, and then I can add my hydrogens if I want here. Okay, so anyways, that's carboxylic acids. So the next thing we need to talk about are properties of carboxylic acids. So carboxylic acids are weak acids. Okay, and you'll actually see different ones like ethanoic acid, well, acetic acid, that's actually vinegar. And so you'll see that these are weak acids if you were to look in the relative strength of acids chart in your data booklet. Okay, but one thing to note is the an acid-base reaction. So if an ethanoic acid was to react with water, what you'll actually end up seeing is the acid is going to donate its proton or a hydrogen ion, and the base is going to be an acceptor. So if you take a look here, you'll actually see that structure. This alcohol is going to donate its hydrogen to water, then it becomes hydronium ion, and then that acetic acid or ethanoic acid is going to lose a hydrogen, and then we're going to see our conjugate base come out here. Okay, but again, acids, an example of one would be vinegar, and they're weak acids, but they have that carboxyl or carboxyl, carbonyl, and hydroxyl attached to the ends of them. And I believe that is all I have in terms of carboxylic acids. Hopefully that's been helpful. If you want some additional practice, just email me and I'll send you some information that can provide you with that practice. Okay? Anyways, we'll see you on the next video on esters.